Will you consider this? You're from Texas, you get drafted, you go to California, you go to many other places, and you land in central Illinois in Galesburg, and Ray Whitehead, who is the founder and CEO of Jupiter Machine and Tool, and Pegasus Manufacturing. That's a lot. That's a lot packed in there.
It is a lot to say.
So tell me exactly. First of all, let's hear about Ray Whitehead before we find out about what you founded.
Well, briefly, as I've said, I'm raised on a cattle ranch in Texas. I wanted to be an electronics engineer, and at the time frame when I got into college in Texas, they dropped the college deferment and had a lottery for the draft. My number was number 2 in this lottery on a national lottery. I've never won a lottery since. I don't win at bingo at church even. But 10 years later, I got out of the United States Air Force, mainly because we had moved so many times in 10 years. And briefly went to work for several years for General Dynamics down in Southern California. Worked on the Stinger missile phalanx gun system. So my background in the military deals with tactical radar, encryption, and the A-10 tactical fighter itself. And then I always say never, because I started riding Harleys, and I became the director of manufacturing of American Eagle Motorcycle Company.
Really?
And that's how an electronics engineer starts building mechanical devices and parts. So we had a great time. They wanted to move to Southern California. My wife is from San Francisco. So here you have a Texas cowboy marrying a lady from San Francisco. It's worked for 30 years. But we were in Sacramento, so we decided to stay there and move to Silicon Valley. And there, I ran a company called Accurate Technology. We produce all the parts for Fox Shocks, Fox Racing. Mm-hmm. When you say Fox, most people think of ATVs, dirt bikes, that kind of things. But Fox has a defense division that builds shocks for Humvees. Mm-hmm. And then somewhere along the line, Ruth and I got together and we decided that we wanted to start our own company, and we founded Pegasus Manufacturing.
All right, so that's an interesting name. It's very Greek. And why did you name it Pegasus Manufacturing?
Ma'am, I was raised on a cattle ranch with horses, mm-hmm. and it is obviously a horse. And so it was close to my heart, and that's how we came. Known for speed, accuracy, and so a CNC machine shop business is also known for the same thing. So,
okay, I told you that before we started recording, I told you I really had to look up CNC because I had no idea what it is. And there might be one or two viewers out there who don't know either. So what is a CNC machine?
Sure. It stands for computer numerically controlled, but the CNC machine is essentially an automated way to make metal parts. It started with probably your grandfather or great-grandfather with a CNC or a manual lathe or a manual mill or out in the barn or something. Mm-hmm. And today this is a fully automated industry that the CNC machine is at the heart of. It's the mothership of all manufacturing, directly or indirectly. Whether it's molds that builds plastic or whether it's actual parts themselves, it is truly the mothership of all manufacturing itself. And here's the interesting thing. It was actually founded in the state of Illinois years ago. And so as that industry grew with names here in the state of Illinois like Sunstrand and Ingersoll, most of those in the Chicago area, through the years, it then became a situation where it was offshore to Japan and ultimately to Germany, and now fast forward to 2025.
I'm coming back here.
You have all of the machines that are virtually made offshore except one company in California called Haas, and they produce 8% of the machines.
Only 8%?
Yes, ma'am.
Do you think with things that are changing now, do you think that a lot of this will be coming back to the United States, or do you have an inkling on that?
Today there's a lot of focus on reshoring. And in the case of Pegasus, as a user of CNC machines, that manufactures all kinds of parts from medical to defense to all food service and so on. The other company that we founded was Jupiter Machine Tool.
Mm-hmm. Another original name.
Yes,
explain that. Go ahead.
The way that we came up with Jupiter Machine Tool was it was actually Ruth's idea, and it is a name, a word, it's a planet that's non-translatable in all languages. So the word Jupiter on a global basis is still pronounced Jupiter.
Okay.
You may notice on my jacket there's a 2-4 here.
Right.
This 2-4 is reminiscent and stands for the fact that we're able to conduct field service on a global basis using direct and augmented reality 24 hours a day. So hence the 2-4. And actually Ruth created this logo itself.
You married up.
Well, I lucked out every now and then. I mean, every year at our anniversary, she says, well, babe, we're going to try it just one more time.
There you go. So, all right, so you're from Texas, go to California. Well, you were all over the world with the military, and thank you for your service, by the way.
Thank you.
How did you end up in Galesburg, Illinois?
You know, Christine, if I had $1 for every time I was asked that question, it was an accident, actually, so to speak.
A good accident.
We produce parts in California for a company that's local here, Heat and Control. They are a food processing manufacturing company, and their headquarters is in Hayward, California. And Pegasus was producing parts for Heat and Control. And the president called me in and asked me if I'd be interested in moving to Illinois to help them with their supply chain issues locally.
And when was that?
That was, oh my God, about almost 11 years ago now.
Okay.
My wife reminds me of that. Her mother's still in Morgan Hill, California, so when February comes, she calls and says what the temperature's like there compared to here. So it's about 11 years ago.
Right, okay. But so he called and said, do you want to move here? And what made you to make that decision?
We came out and we visited Denise Leo, who's the managing director here of Heat and Control, an amazing woman. And let me just say before we forget this, the entire CNC manufacturing industry is not a man's industry. It is much better off when you have both females and males mixed in that mix because you get a better product, a better environment, and lots of different perspectives to look at manufacturing.
Absolutely. For the input on how it might work better. That
and how it's designed. I mean, there's some great engineers. Denise Leo is one of those. She's a great leader, and she does a wonderful job, and that was the first one I met. And Denise made me feel really comfortable, and of course we were offered a very long-term manufacturing contract to arrive in Galesburg, Illinois.
And other than snow in the winter, you don't mind it too much?
Yeah, it's pretty nice actually. We live in East Galesburg, and we like it out there, and we've become part of the community, and we now know people, and it seems like home.
And from what I understand, you still have horses, so part of your Texan came with you.
Yes, ma'am. I still have two horses, both raised as colts.
All right, so tell me what you do. We have samples of things here, and I'm not even going to try it. I can pick this one up. I'm good with it. It weighs maybe not even a pound. But the rest of them, one part's for an auger, so that's really good in farm country here. And what else do you do? Did I read that you're also involved with SpaceX?
Yes. So the strategy of what Pegasus and Jupiter is doing collectively together, essentially Jupiter Machine Tool designs, installs, and services CNC machines, and most of its people was a spinoff of Caterpillar originally, and they were part of a local company, Advanced Technical Services, ATS. And then when we moved to Galesburg, we purchased a service company called Dartech. And so then we got in the CNC machine business in the Jupiter side of things. And so there we began to design in the corrective actions for all the failures in all brands of machines. We work on and still service. We do service for CAT, we do it for John Deere, we do it for SpaceX, we do it for Lockheed Martin, and so on. So the issue was we wanted to get into building our own machines and designing them in the United States. And so that's kind of how that began. But here, today in 2025, the focus of advanced manufacturing relies on three fundamental cornerstones. One is robotic automation, and we have an automation facility in Huntsville, Alabama, with really some great automation folks. The next one is 5-axis machining, because you can produce very complicated parts. And the last one is leading edge for 3D metal printing, so we're able to print the part like you would print in plastic, except this is 24 kinds of metal.
Really?
And then we actually machine it and finish it. And the industry we support with that technology is sitting here on the table. For example, this is a part that was actually printed, but if you look at it, it's like an exhaust header, but there's no welding in it. It's a solid one piece. That's never been done before.
So that's been printed in your 3D printer?
That's correct.
Okay.
This part out here in the front is
This-
a rocket nozzle. And on the side that's facing the camera, you can see there's some air passageways. So when we put those passageways in there and then print the outside, it is a way of producing the part that we've never been able to produce before ever in history. Historically, we would machine a part like that, wrap the outside around it, and so on. So the other thing about 3D metal printing and CNC machines combined with automation is something like this. Can I pick this up?
Yes.
Is that okay?
Yes.
This is a part, it's an aerospace type part. But to give you an example, notice that a lot of this part is open here, it's the big hole. When you produce this out of a solid piece of metal, like this one is solid, when you do that, you lose a lot of material. This part's made out of Inconel. It costs $400 to make the part at material cost in a solid piece. When we print it, we're printing only the part we need, and then we're machining a very small amount off and we're finished. So the $400 goes to $18 in cost of material. That's what 3D metal printing can do for you.
Really?
It also has no limitation as it relates to the shape, how it's built, without regard to the size. So in a hybrid CNC machine, you can only make a part as big as the machine. But if we start printing the part with the robot, if we move the robot, we can make the part almost infinite in size. For example, Boeing right now is experimenting with printing aircraft fuselages in one piece. SpaceX, if you've ever seen the 3 pictures of SpaceX, where you start with, there's 3 samples. One has just got all kinds of tubes, and that's how it was built originally.
Right.
When you look at the printed part, it's 10,000 pounds lighter and several $100,000 cheaper. So it gives us the ability to support logistics of aging equipment. If you've ever been in the ag business and you have a shaft or you have a combine or you have any of that you can't get anymore. The parts for. Here you can scan the old parts and then we can print it and make a new part. Or we can print part of it and refinish it for you. And there's a few other things. Pegasus also is involved indirectly with the medical industry. It's using a Jupiter machine. It is building parts in Galesburg for the Da Vinci robotics surgical system itself.
All right. That's where you
Yes, ma'am.
put your hand in and do it.
That's exactly correct.
Right.
But the other thing that we're now looking into is with OSF Hospital Group and JUMP is the ability to print 3D metal body implant parts. And the reason for that, like shoulders, knees, hips, that kind of stuff. The reason for that is that one, for the first time, we can make a part out of multiple metals. In the case of a shoulder implant, it's titanium based and we add copper. The copper's added so you reduce the risk of staph infection. So for the first time in history, we can literally print and make parts as we go. And we have a project with Caterpillar right now. We have another one with a number of other companies. And it gives us an ability we've never had before. And Jupiter Machine Tool is the company that's developing an advanced version of these 5-axis machines. So advanced manufacturing today is the consortium and the amalgamation of robotics integration, of 5-axis machining, and 3D metal printing, advanced 3D metal printing. When you combine all of those 3 together, which is what we do at Jupiter Machine Tool, then you have a lot of work for the future, and we're here to grow the company and expand and increase our employee base.
So what requirements do your employees have? Do they have to have engineering degrees as well, or how does that work?
The simple answer is all the above.
Okay.
And since you asked about Galesburg, I'll just say one of our biggest challenges once we moved here was recruiting employees to Galesburg. To us, it's a beautiful little community. We came from Silicon Valley, 30 minutes to Peoria, 35 minutes to Moline. No traffic at all. We thought this is wonderful. But we had trouble with that. So in order to kickstart this, we donated a machine, a CNC machine, to Galesburg High School. And that started a vocational technology training class, of which there were only 6 students then. Now, almost 9 years later, there's 270. That central core draws from 8 different high schools. And so the next thing for us now is when you look at the employee base itself, we need all the above. We take on students directly from high schools. We'll take them from colleges, there's a certain part of this we need advanced engineers. There's other parts that we need 5-axis CNC machine people. We need all of that to grow the entire business base.
Quite interesting. So companies come to you and say, okay, we need a replacement part, or how can we make this better? Do you have any flops? Have they come to you with some pretty poor ideas and it's like, okay, that's probably not going to work with your engineering background?
There's always that. In all of engineering, no matter what field you're in, there's always compromise. There's a cost-benefit relationship to the outcome, one way or the other. And so, yeah, there are cases that this kind of technology is not that well suited for. In high production volume today at Pegasus in Galesburg, there we produce 30,000 parts a month for GMC trucks, for the half-ton, three-quarter-ton, one-ton trucks. And that is a volume from a forging that you wouldn't want to do in a 3D printing approach. On the other hand, if you need low quantities of things, you can print them in a CNC hybrid machine without the cost of tooling. Tooling means the amount of work holding that you've got to build first before you can make the part. In the case of forging dies, it's about 50 to 80,000. In the case of plastic injection molds, it's 50 to 100,000. Here, we can print the part without having to design tooling at all. So it fast forwards, shortens up the timeline, reduces the cost. So there's many applications, and it always depends on the application itself. So when we were talking about some of this, in fact, I hope you don't mind, but I brought something for you.
Can't wait.
If you would, this is not an engagement ring,
okay.
I promise.
No, okay.
If you would just take that, open it up.
Well, it's light. It's lighter than some of those other things.
It is.
Let's see.
So when you look at this part, what this is a part that we're able to put together. It takes almost 16 hours of machine time. But what we're trying to demonstrate is the range of our capabilities.
Okay.
From very small, accurate parts. By the way, you can't take the ball out of the box, it won't come out.
It's not one of those little quizzes that.
No, ma'am, It's not. You just can't take it out. It demonstrates
awesome.
a technical capability. So from small parts to very large parts, we're able to handle the width and breadth of that as it ranges from the shape of the part to the application of the material of the part. It's pretty straightforward.
So how many different types of metals do you use, and do you find out if there's combinations that work together better?
It starts always with the application of what's the engineer's looking for. Like this part right here is not made out of stainless steel. It's made out of Inconel. That's why it's so expensive.
Right.
And some of the exotic parts in aerospace like Inconel, Monel, Hostilloy, things like that are extremely expensive. And they have like space applications, so very cold temperatures, very high temperature capability, extremely strong strength versus weight ratios. It's not a simple subject to answer, but it is one that we're able to identify and work with a lot of them, not all of them. We're not there yet. But most of the normal stuff that companies use, 4140, all the steels, stainless steels, alloys, and things like that is possible.
And then you just ship these things all over the world, or do you?
No.
Just all over the United States?
When it comes to the 5-axis machines,
okay.
There's a security agreement between the Japanese and the U.S. government about these 5-axis controls. And Fanuc is a very well-known 5-axis manufacturer. They're also a large producer of robotics. Their headquarters is in Chicago and Hoffman Estates. And most of our business, the sensitive parts comes from there. They are controlled from an export standpoint, from a security standpoint. And it's not about just the military, it's just generally what you can produce with these things.
So what's the next thing? You're working with SpaceX. You make some parts for Apple, did I
Actually,
hear
that's
that?
a strange, yes, we do. We do build the test sets for Apple for the iPhone 5 series, and we did that in California. And it was crazy. Well, if you don't mind, I'll tell you the story.
You just go ahead.
I had the head of Apple engineering from Cupertino call me one afternoon on a Friday afternoon and said, hey, we have a problem with our iPhones. And I think it was the iPhone 3 at the time. And I said, so what's the problem? He says, well, we have problems with test. And if you put it in your back pocket, it fails.
Oh.
So we need a test set designed quickly, and we did that. And then they wanted a destructive test set. So today, still, now following us to Galesburg, Illinois, We built a lot of the test sets for Apple for their iPhone series, and these things are actually exported to China for test.
So, okay, so what kind of a test do they run on it?
It's destructive.
Okay, so I remember from when we were growing up, the Timex, you can stomp on it and do all that stuff, yeah.
Actually, that's a very good analogy, Christine.
Okay.
That's pretty good. This thing, it's a drop test, and it tinker toys down through a tube, moves back and forth, and randomly hits a granite plate about 22 feet later in varying random angles.
Okay, and if it holds up, you're good to go.
That's right.
So you're hired for till the next phone comes out.
Yes, ma'am.
Okay.
Well, they do this continually. It's
All
a
right.
percentage of their production.
So your vision for Galesburg, and to have that many kids in a vocational program right now is really pretty progressive. I mean, because when did they start getting rid of some of those programs in our country?
In the late 70s,
Yeah.
and it's just continued. The vision is not just for Galesburg, it's for Peoria and Moline. We're talking about a revolutionizing technology that's at the forefront of manufacturing on a global basis. And it could well have, I would think that we would be able to also support this on a statewide level. We are currently, with Pegasus and Jupiter, involved in a number of these organizations. One is called QCMI. This stands for Quad City and Manufacturing Institute. But the colleges we're involved with there is University of Illinois, Illinois State, University of Iowa, Iowa State, and Western. So this is a consortium of developing new technology collectively together. The same thing is true. We've been asked to join the steering committee and the board for quantum. As you probably know, quantum is a very large initiative in the state. Almost, it's in the billions. I think they're building a new building up by Chicago, and they've asked us to be part of that for this end of the state and the applications. So there's a lot of things. This is Illinois' chance, in my view, to stop decrementing manufacturing to other states and start reattracting people and companies to the state of Illinois.
I like that. And you're a transplant. You see the value of the people here because
Absolutely.
they're big hearts.
You know, I'm glad you said that. When I first moved here, I just simply realized in the first winter that I say this to everybody I meet. The people in the Midwest have a big heart, and all they need is an opportunity. And here's how I prove it. In the winter, if you slide off the road, someone here is going to stop and help you. In California, where we came from, if your car's broken down, the only phone call that's going to help you is AAA. Other than that, you'll sit there forever. So the people in the Midwest really want to do a good job. They want that opportunity. We're trying to provide that, and we need the help of the communities, the state, the federal government, and specifically getting the word out. Our biggest challenge is no one knows who Jupiter is. We build world-class machines, and we're not a historical label that's been around for 30 or 40 years.
But you're making a name for yourself, and
Yes, ma'am.
that we got to get that name out there.
Yes, ma'am.
I love it. I love it. And so you're here to stay, and we are, what would you name it? It wouldn't be Silicon Valley anymore. What would it be if it ends up doing what you can foresee it becoming? Ruth will come up with a name for it.
I was just going to say, I think we have to refer that to the lady that's been so successful at being creative at those kinds of answers.
Okay, well, that's great. So what do we do in the meantime, really quickly?
What we do right now is the key to our future always lies within the kids. And that's why we've gotten involved so heavily with education. First, it was we needed the labor pool, but now I had a young man knock on my door not too long ago and simply say, I want to show you something. I went out to look at this. He had just bought a brand new little car, it's really cool. Showed me every door, and I think of my own 1968 experience with a Camaro, and I had a Chevelle in those days. He was so proud, and he simply said to me, without this job and without this opportunity, I would have never been able to afford this. So the answer is, we need to collectively get together, help each other to expand this technology. About 4 years ago, I was asked to join a meeting one day and talk to the people of which Doug Oberhelm was there. And the question was, how do you grow Peoria? And my first answer, which was tough for me to say, sitting next to Doug Oberhelm from CAT,
Right.
was to say the first thing you have to do is stop bleeding on Caterpillar.
Right.
And I said, you need to develop an advanced technology that this place is known for on a national and global basis, and the rest will come. And that is what you have here. You have a chance to do this, and I think we could put this together in a way that it would scale. It wouldn't be just about us. We could grow this ecosystem.
I like it. Well, I think you're on your way. So thank you very much for coming to Central Illinois. Thank you for joining us and enlightening us about Jupiter and Pegasus. And I hope you've enjoyed it too. And you can get a hold of him at one of those places anytime you have any questions. All right. Until next time, be well.